Extreme physics.
All right. Hopefully everybody's doing okay with the snow. It's snowing here at Physics Central, Extreme Physics Central, here at the basement of Extreme Physics Headquarters. Let's take a look at a more advanced projectile motion problem. We'll have a cliff, another cliff problem. A ball, a snowball. Yes, see, tie in. Snowball is launched at an angle of 37 degrees at 20 meters per second off the top of a cliff. So let's see. So it's going to go something like that, some sort of parabolic motion. How far from the base of the cliff? I'm just going to abbreviate. How far? So d of x equals question mark. All right. How far? Let's see. Let's give ourselves some numbers. We're going to call the beginning 0 when it reaches its maximum height 1, and when it just before it lands 2. All right. How far? Let's see. How about what else could we? How about velocity at 2? What's the velocity at 2 when it hits the ground? Max height above edge of cliff. All right. Just so we know, this is the edge of the cliff, and this is the base of the cliff. I've had students be confused by that. That's the edge. It's the base of the cliff. All right. So, all right. How far does it go? Let's deal with that problem first. Well, we know it's going to move at constant velocity in the x direction, and we know it's going to accelerate downward. And it's actually what's happening vertically, which determines how long it's in the air. First step, let's break this into its components, the velocity vector into its components. We're kind of tight on room here at Physics Central Basement, Extreme Physics Central Basement. So I'm going to actually draw the initial velocity vector here and break it into its components here. We might get a little tight, but you know, we're okay with that because we're solid students. All right, there's our velocity, and we're going to break this into its x and y components. What happens in the x direction stays in the x direction. What happens in the y stays in the y. So velocity in the x initially is 20 meters per second times the cosine of 37 degrees. Wow, that's a terrible pen. I'm not going to use that anymore. It's all squished. Velocity in the y direction equals 20 meters per second times the sine of 37 degrees. All right, breaking that vector into components. Should I calculate that? Why not? All right, carrying extra digits for intermediate calculations. So let's set up what's happening. We have in the x direction and in the y direction. All right. X direction is always quite simple because we have constant velocity. The difficulty occurs in the y direction, at least more work. So v in the x direction is 15.97 meters per second. All right, and that stays constant. And the reason it stays constant, of course, is that if we draw a free body diagram of our projectile, of our snowball in flight, there are no contact forces. The only force acting on it is the force of gravity. So therefore, there's only one force, that is the net force, so it's also accelerating down in that direction. Okay, no forces horizontally, so it's a constant velocity or at rest in the horizontal direction. But we know it's not at rest. It started off with a velocity. So anyways, constant velocity, constant acceleration. All right. V initial, V0 in the y direction is 12.04 meters per second. All right, there we go. You know, and we of course we have the acceleration is is downward. We have a net force downward. And what else do we have? 30 meters it's going to fall. So the distance from 0 to 2 is negative 30 meters. That's actually the displacement is negative 30 meters. And what else we want to know? What we're going to do is we want to know the distance here. If we have velocity and distance, we're going to need to know the time. All right. So we're going to calculate time in the y direction. What happens vertically determines how long the flight lasts. I think we have enough information to solve for time. Yes, we do. We can use El Grande. D equals V0 T plus 1/2 AT squared. All right. V0 is not 0 now. Now we have this quadratic. I think what I'll do, rather than solve this quadratic, because I don't have those fancy graphing calculators handy, I just have a scientific one. What I'll do is I'll do it as 2 steps. You could solve this directly. You have all this stuff. You have that. You have that. You have that. You can solve for t, solving that quadratic. Go ahead and do that if you like to do that. I'll do it as 2 steps, but it won't require me to use the quadratic formula. What I think I'll do is solve for V2, because we're going to need that anyways. So let's solve for V2. So let's see. So we have V2 squared equals V0 squared plus 2 times acceleration, distance 0 to 2. All right, so I can solve that. I have all those things. V2 equals plus or minus the square root of 12.04 meters per second squared plus 2 times negative 9.81 meters per second squared times negative 30 meters. All right, there we go. So that is the velocity we have. And at this point, we know it's going to be a negative velocity. It's going to be going down. So we're going to take the negative answer to that. We lose the direction in the math, and we have to look at the physical situation to figure out what direction it is. Minus 27 meters per second. All right, so that's V2. We're going to need that in a moment anyways. So we have V2, and now we can just use V2 equals V0 plus AT, and we could solve for t. So there t equals V final minus V0 all over A. V final minus 27.08 meters per second minus V initial 12.04 meters per second divided by negative 9.81 meters per second squared. All right, let's see. Let's go with 3.98 seconds. All right, so that's how long it's in the air, so 3.98 seconds. Remember, that's the only thing they share is time, because this is actually the same motion. When one stops, the other stops. But everything else stays separate. So let's see. The distance equals average velocity times time is... I'm not going to fill this in. Well, I better, because otherwise people will start doing this on the test. Meters per second times 3.98 seconds equals 63.7 meters. All right. So that's how far. It's about 64 meters. So it traveled, it's going to land at 63.7 meters. All right. I'm going to have to start erasing. So let's calculate V2. All right, so we have V2y and we have V2x. So that's easy. When it gets down here, we have V2, right? So when the ball gets to the bottom, it's got a velocity Vx, and it has a velocity Vy, which is bigger. Am I off the board? I might be off the board. I don't know. Vx and Vy, those are going to add up to actually give you give you what the velocity is. So this is actually the velocity vector here. And we're going to want to calculate this angle. All right. Well, Vx is 15.9, almost 16 meters per second. Vy is negative 27. So let's calculate the magnitude of V. So Vx, of course, is 15.97 meters per second. Vy is 27.08 meters per second. I don't have to put the negative there because I'm showing it's downward. The negative just tells me the direction. So let's calculate V. The magnitude of V, anyways. The magnitude of V is the square root of 15.97 meters per second squared plus 27.08 meters per second, the whole quantity squared. I have 31.4 meters per second is the magnitude. And the angle is, let's see, we have the opposite side and the adjacent side. We're going to use tangent. So we'll use inverse tangent to find that. So the angle is going to equal inverse tangent of opposite over adjacent. The opposite side, of course, is Vy, and the adjacent side is Vx. So tangent of 27.08 meters per second divided by 15.97 meters per second. All right. And I have about 60 degrees, 59.5 degrees. Does that make sense? Yeah, it should be more than 45 because it's more down than that. All right, I'll buy that. So the velocity at the end was 31.4 meters per second at 59.5 degrees below horizontal. Below the horizontal. All right. All right, there we go. There's our ending velocity. Right there. All right, I accidentally erased the X information, but I don't need the X information to figure out how high it goes above the edge of the cliff. I just need to know how fast it's going upward, and then I still have that. I still have my acceleration. Well, when it gets to 1, it's going to stop in the Y direction. It doesn't stop. It's still going at, I don't know, 15 meters per second, 16, whatever it was. Don't remember what it was. 16 maybe, that way. So distance from 0 to 1 equals question mark. It's because we asked for the height above the edge of the cliff. All right, so this should be easy enough. We're going to use square E. V1 squared equals V0 squared plus 2AD. And so the distance is displacement, actually, equals this. All right, solving that. V1 squared, 0 squared, minus 12.04 meters per second squared, negative 9.81 meters per second squared. 7.39 meters. Let's see. Let's see. It stops going up after about 1 second, and after 1 second, the average speed is 5. All right, that seems reasonable. What I did was I said, okay, so how long is it going up? Well, that's about 10 meters per second. So it's going up for about 1 second. This is how I just saw if this is a reasonable answer. So it's going up for about 1 second. And the average speed for that 1 second would be the average between 10 and 0. So the average speed would be about 5 meters per second. How high would it go? So if I had something going for 1 second at an average speed of 5 meters per second, it would travel 5 meters, all right? Well, this was going a little faster than that. This was going 12, so 7 meters seems reasonable. It's close to 5 So, all right, seems like a reasonable answer. All right, I hope you're staying warm. I'm going to give you some additional problems because I didn't know we were going to have a week of school off. Wasn't planning for that. Hopefully this helped you with your projectiles because we're going to need to move on from projectiles quickly now because we lost a week of school. So, all right, I will see you, I don't know when. I think Monday, but who knows?
Extreme Treasure.